It sounds like the fever dream of an alchemist or a plot twist from a sci-fi thriller. Hook up an old mouse to a young one so they share blood, and watch as the older animal's tissues begin to reverse age. Muscles strengthen. Brains sprout new neurons. Skin firms up. Hearts beat stronger. No potions, no pills, just shared circulation. But this isn't fiction. It's the strange, real, and still unfolding world of heterochronic parabiosis, a research technique that has reignited serious scientific interest in the possibility that something in young blood can slow, or even partially reverse, the biological clock. Parabiosis, literally living beside, was first developed over a century ago, mostly as a physiological curiosity. In its modern form, it involves surgically joining two mice so that their circulatory systems become one. When one is young and the other is old, the experiment becomes heterochronic, and the results are hard to ignore. Over the past 2 decades, researchers have shown that old mice exposed to young blood experience a surprising burst of regenerative activity. Their livers regenerate faster. Their muscles heal better. Their hearts pump more efficiently. Their brains show improved memory and increased plasticity. Meanwhile, young mice exposed to old blood? Well, they age faster. Their tissues slow down. Their brains fog up. It's a one-way gift. Youth is generous. Old age less so. So, what's in this rejuvenating cocktail of youth? That's the billion-dollar question, and researchers have been on a molecular treasure hunt ever since. Several candidate factors have been identified. GDF11, growth differentiation factor 11, made headlines for its apparent ability to restore youthful function in cardiac and neural tissues. Some studies found that injecting old mice with GDF11 mimicked the benefits of young blood, improving cognition and vascular plasticity. Others challenged the findings, noting that GDF11 may decrease with age in some tissues, but increase in others, or that it overlaps functionally with pro-aging factors like myostatin. The GDF11 saga has become a cautionary tale about oversimplifying the biochemistry of youth. Another promising molecule is oxytocin, the so-called love hormone, which increases with social bonding and also shows tissue regenerative effects in muscle. Then there's TMP2, a protein that regulates tissue remodeling and has been shown to improve cognition when derived from umbilical cord plasma. A few studies even suggest that extracellular vesicles, tiny membrane-bound packages full of RNA and proteins, may act as the actual delivery system for youth-promoting messages across tissues. What's more, the anti-aging magic of young blood may not depend on boosting regenerative factors alone. It may also involve diluting pro-aging signals. Studies from Irina Conboy's lab have shown that simply removing some old plasma and replacing it with saline and albumin, a protein replacement, can lead to many of the same rejuvenating effects seen in parabiosis. This suggests that aging might not be just about what we lack, but what we accumulate. Inflammatory cytokines, senescence-associated factors, oxidized lipids, and other noise that builds up in the bloodstream over time. Clear out the clutter, and your tissues may regain their youthful clarity. Of course, all of this has created a predictable ripple in the public imagination. The idea of young blood transfusions as an anti-aging therapy sparked both biohacker enthusiasm and bioethical horror. Startups began offering young plasma infusions for thousands of dollars per bag. The FDA responded swiftly, warning that such procedures were unproven, potentially dangerous, and deeply irresponsible. While the science is intriguing, we're still far from knowing whether these results in mice can translate safely to humans. For now, the only truly rejuvenating experience from young blood is the academic curiosity it fuels. Still, the principle behind parabiosis may lead to real breakthroughs. By isolating the molecular differences between young and old plasma across thousands of metabolites, cytokines, hormones, and exosomes, scientists are beginning to map the shifting terrain of the aging circulatory system. This map could guide everything from new diagnostics, biological age markers in blood, to targeted therapies that enhance regeneration without needing an actual donor. Think precision medicine, not vampire myths. In the end, parabiosis is more than just a macabre curiosity. It's a window into how deeply connected our circulatory system is to the state of every tissue in the body. Blood isn't just a delivery service. It's a conductor, a communicator, a chemical census of age. And as science advances, we may be able to rewrite its message, replacing entropy and exhaustion with clarity, repair, and resilience. Not by stealing youth from others, but by understanding how youth is written into the bloodstream, molecule by molecule.